Okay, welcome everybody to the afternoon session. Hopefully everybody enjoyed lunch and we're ready to go. So plenty of places left, have a seat. This session is titled Agile Deployment of Predictive Analytics on Hadoop, Faster Insights Through Open Standards. And going to the first slide, my co-presenter today will be Rueckert. And I already made a slight mistake here on the slides. It says data scientist, but someone actually handed out a sticker said data nerd, so I guess titles changed already. My name is Michael Zeller. I'm the CEO of Zementis. This joint presentation will cover not just a few slides, but also an interactive demo where we showcase you a little bit what we mean by the deployment of predictive analytics today. We'll try to cover three main topics. One is really how to effectively deliver predictive solutions using three major elements like model development. How do you analyze data? How do you build models, predictive models, for example, in R, open source tools like R and 9, or commercial tools. We will then cover how do you actually deploy those, execute them on top of Hadoop. And that's really the combination that the partnership between Datameer and Zementis provides. So there's the Zementis Universal PML plugin that sits on top of Datameer and on top of Hadoop, so to speak, and leverages Hadoop for the scalable infrastructure to execute the models. I hope we will also be able to make you aware of the PML standard. PML stands for Predictive Model Markup Language, which is a vendor-neutral and open standard for predictive analytics. It helps you to really incorporate predictive assets from virtually any commercial and open source tool into your existing infrastructure and apply those models to big data, for example, on top of Hadoop, but also elsewhere. It doesn't have to be big. It can be small and fast in real time. The benefits of the standard we'll cover throughout the presentation. And then hopefully at the end of the day, you'll recognize with the standard you will be able to have a much more lightweight, agile deployment process for predictive assets. So when time to market, when the low cost and complexity is important, this is really, I think, a great way to reuse existing predictive assets that you may already have in your companies and really bring them to the Hadoop platform. So Oli will give you a little bit of an overview on Datameer before I continue.
Hi, so my name is Ulrich. I'm a data scientist at Datameer, and to summarize what Datameer does in a single sentence, basically we do business intelligence on top of Hadoop. So the basic idea is that we have a software that looks and feels and works like a spreadsheet, so it's easy to use and everybody knows how to deal with it. But below that, below the surface, there is the power of Hadoop, so you can, with a single click, crunch petabytes of data. Datameer was established in 2009 by some of the people who contributed to Hadoop even before it was as big as it is right now. And it's been a fun time so far. We managed to have offices in Zementis in New York and Germany, and tons of customers. I have some on the slides. I have more I can talk about, 3 out of the 5 biggest banks in the States. So I hope it's going to be more soon. Right, back to Michael.
Thank you. Zementis, on the other hand, is focused on operational predictive analytics, and typically the presentations I give are less on big data, but more on advanced algorithms, statistical algorithms like neural networks, support vector machines, complex regression models, ensembles, like everybody that might have looked at the Netflix prize. It's an ensemble model that won at the end of the day with hundreds of submodels, and that's really what predictive analytics covers. Zementis is based in San Diego as well as in Hong Kong. And today's topic is really on the Universal PML plugin. In addition, we also have standalone versions that sit outside of Hadoop infrastructure. It's called Adapa. It's a decision engine that includes predictive analytics and rules. And it's available, for example, on IBM Smart Cloud as well as Amazon EC2. A little unknown fact here is a PML converter that's actually wrapped into the PML plugin. PML has actually a long track history of different versions, and so this allows us to upgrade to the latest version and actually deploy really across a large selection of vendors and versions. We primarily operate through partners. Datameer is one of our strategic partners for the Hadoop world. But we also offer in-database scoring solutions. So if you don't want to move to a Hadoop, you'd like to be more structured, then Sybase, for example, Sybase IQ is one of our solutions, EMC Greenplum, Netezza, and that allows you to kind of bridge with the same models both worlds. So they can live in Hadoop, they can live in your database. As I mentioned, primarily I present on predictive analytics, and so I don't have to cover really that there's big data. It seems to be a recurring question that comes up on the predictive side, that there's big data, and everybody defines it differently. I'll spare that today, of course. For us, it's basically just a collection of either people data or like social media data, transaction records, risk scores, for example, but also sensor data, the energy smart grid being one of them, predictive maintenance and quality control another one. There's two types of analytics. One is, if you wish, the classical BI, reporting, looking backward in history and see what happened. Analyze the data that you have and try and figure out what happened in the past. Today we'll actually focus on predictive analytics, so turning the other way, looking forward rather than through the rearview mirror, and try to answer the question, what will happen next? So predict the next best action for your customer interaction. Predict the potential failure of a mechanical device. Really taking the data, building predictive models, and then applying those models to make better decisions looking forward. And applying those models has been traditionally very difficult. The great tools are, for example, as an open source tool, KNIME that we will see today, another open source option, or SPSS, IBM's tools, SAS, to build predictive model. But the traditional gap that we see in the market is that it's very difficult to apply those models once you've built them to inside of your operational infrastructure. And that's what we call operational and predictive analytics. You may have different groups, different stakeholders in your company that build predictive models, and eventually someone writes up a requirements document that then translates that model into some operational system. And 6 or 9 months or even longer after that model is actually available to you to apply to new data. And that doesn't have to be that way. Really, with the standard that we'll cover today, it's a click of a button. It's an export function, basically, as part of your tool that can allow you to move those predictive assets anywhere they need to live and anywhere they need to tick within your operational infrastructure and actually make money for your company. So it's really the transition from model building to model deployment. On the left side, you see all the great tools that support the PML standard. The list is actually much longer, but that's all I could fit here on the slides. And then once you export your predictive model, once you build the model and you export it in PML format, then basically it allows us to transition it over into Datameer through the Universal PML plugin, or short UPPI. And then in Datameer, it basically becomes a simple deployment execution. You upload the files, it basically turns each PML model, each predictive model, into a custom function, and you seamlessly apply that function to any data that you have already sitting in Hadoop. It's really powerful and very simple, and that's really what we're going for. Simplicity, making predictive analytics transition very fast into your operational environment, wherever that may be. PML as the standard has been around for more than 10 years. So it's a very mature standard, and it's been developed by the Data Mining Group, which is a vendor-neutral consortium. It's an XML-based language, so think about it as your HTML is the standard for all your web browsers. This is your standard for predictive models. It represents statistical data mining models as well as their pre- and post-processing functions, so derived values, missing value treatment, outliers, plus a whole long list of predictive functions, be it regression, be it neural networks, support vector machines, decision trees. The list goes on and on. So a very large set of predictive functions that are available to you. And very important, of course, it is supported by all leading data mining tools, commercial and open source. At the essence of it, it's really a clear separation of tasks. So the analytics team can focus on building the best model with whatever data mining tool fits the job best. You don't have to force a user of a specific tool set to use another tool set because that's what you happen to have in your infrastructure. It's really, excuse me, it's really easy to transition any kind of PML model, be it out of SAS or SPSS or R, into your operational environment. So clear separation of tasks between IT and analytics. And at the end of the day, what it is a benefit for your business side to have a much more agile way to deploy, to have an infrastructure approach to scale models, to apply them to either very, very large data volumes on top of Hadoop, or to apply them to real-time situations where you have minimal latency requirements in milliseconds or microseconds you need to respond, and you need to apply that model, maybe on small data, of course. So at the end of the day, that allows you, if you implement the standard consistently across your infrastructure, to integrate predictive assets across all system and processes. So you can call them directly within your business process. You can integrate them within your CRM system, within your ERP system. You can even call them directly out of Excel. And of course, you can embed them directly within Hadoop and Datameer as a user interface. They can transition into a cloud-based environment. The neat idea here is you don't have to worry about where your models live afterwards, where you actually would like to apply them. It's one standard process, one model building process that your analytics team needs to fulfill, deliver that model, and you apply them wherever it is, wherever you see the best fit. So at the end of the day, it's also a very easy requirements definition. So predictive scientists are very rare, so we have a shortage on it today. If you look at McKinsey's study, for example, predicting that there's a massive shortage in the future of data scientists in general. So here it allows you to actually partner with external consulting companies, simply give them a requirement that says, deliver this model to me in PML standard format, and I know I can own this model afterwards. I don't have to worry about custom code. I don't have to worry about cryptic descriptions of models that nobody understands 6 months down the line. It's an XML standard-based format. I can do that across different divisions in my company. I can do that across external service providers and, of course, across all my applications. So overall, business agility is what you're looking for here in applying a common platform and a common standard. And while I get to walk you through a lot of slides and theory, Uli will actually give you a demo of that simplicity. The setup we're trying to achieve here is to show you an end-to-end model development lifecycle. Think it's it as your software development lifecycle. You do data analysis, and you understand your client's data. You build a certain model or many models, really that predict or are supposed to predict certain events, say customer risk of attrition. And then you develop those models over and over again. You test them. It becomes an iterative cycle. But a key part of that is, of course, the model deployment cycle of that. So as you're done developing the best model you can find, how do you actually transition it over to your operational infrastructure? And the glue, really, between all of those is the PML standard. So what we're going to show you today is really the glue between Hadoop and Datameer sitting on top of Hadoop, NIME as the model development environment, and the universal PML plugin to actually make those functions, those models available in Datameer for immediate execution.
All right, thank you. So I'm going to give the demo, and so the setup for the demo is it's a kind of a use case. It's real data from a bank, and the bank is doing an annual marketing campaign. And this year in 2012, they're trying to be a little bit smarter about their marketing campaign. Instead of calling all of their customers, which takes time and money, they decided to just target these customers which are most likely to actually buy the product and respond to the campaign. So in other words, what they're looking for is they're looking for a predictive model that tells them, is this customer likely to buy the product and respond to the campaign? And luckily, they still have data from last year's campaign, so they can go back and look at the data from last year and see who actually bought after he was targeted. And now, how do you learn such a model? Usually, that's a kind of an iterative process. So usually what you would do is you would do 3 steps. First of all, you would split the data you have from last year into two parts, the training set and the test set. And then from the training set, you would use some statistical algorithm, like a decision tree learner or a support vector machine, to learn a predictive model. You have the model, but what you don't have is you don't have an estimate of how accurate the model is. It could be bad, right? It could just predict noise. So in order to figure out whether it's a good model or not, what you usually do is you look at the second set, the test set, and then you apply the model to the test set. Since you have the actual true label for the test set, you know whether the customer bought or not. You can compare the prediction with the actual truth, and that can give you an estimate of how good the model is. Now, once you have that, once you have that estimate, you can go back and see, okay, the model wasn't that good. Maybe I should tweak some of the parameters. Maybe I should use a different learning algorithm. So you can try to improve your model. And finally, after a few iterations, once your model is good enough for whatever you want to do, then you take that model and then you deploy it and apply it on the 2012 data to figure out which customer should be targeted and which not. All right, let me show you how this I'm not going to demonstrate the whole process because that would be quite a lot, but let me show you how like a subset of that stuff would look like in Datameer. So in Datameer, what we have is we have that idea that you should be able to deal with data in a spreadsheet way. So here I have the data already imported into Datameer. I have information about the customers. I have a column that gives the age, job, education, and so on. And our first task would be to split the data into two parts randomly, one part for the training set and one part for the test set. So in order to do that, the first thing I'd like to do is I'd like to duplicate the worksheet because I don't want to work on the actual data. I don't want to change the import job. I just want to work on a copy. Let me give that a better name. Let's say that's the split sheet. And now the second step is that I need to split it randomly into two parts. Now, how do you do randomly in a spreadsheet? Well, it's a spreadsheet, so you can add new fields and new columns. So in our case, we probably would use one of the math functions to add some randomness. And in particular, let's take the rand function, which returns a random number between 0 and 1. So if I click on OK now, I get random numbers here in that column. Let's give that column a slightly better name, maybe random. And so that's good news. I have random data now, and now I can filter. So for instance, I can apply a filter that says if the random number I generated in the random column is less or equal than, let's say, 0.5, then that row should show up in a new sheet. So I create a new sheet, and here we have a sheet that contains about half of the data, right? The random number should be between 0 and 0.5. Let's again give that a better name. Let's say training split, training filter. There's one thing. I still have that column here. I actually don't need it, so what I do is I duplicate the sheet and just get rid of that last column because I don't need it anymore. And again, I'm trying to be German about that. So that's the training data. All right. Now we have half of the data set is for training data. How about the test data? Well, same thing again. Just do a filter, go to the random column. This time we want to have it greater than 0.5. So here we have it. Create a new sheet. That's the test filter. And finally, let's get rid of the random column again because we don't need it. And that's our test data. All right, so now if you might remember that I told you that Datameer is a business intelligence platform on top of Hadoop, and that you will be able to crunch petabytes of data with a click of a button. So did I just work on petabytes of data? Unfortunately not. I didn't tell you that we use a little trick here. So what we do is instead of working off all of the data, when you import the data, we take a subsample of the data for Datameer. So what you get shown here is you get real-time feedback on a subsample of the actual real data. So you can experiment a bit. You can see what's working and what's not working. But as soon as you want to work on all of the data, you have to really start Hadoop and create a MapReduce job. So how can you do that? Easy. Let's save it. Maybe save it in the bank folder and call it a campaign. campaign workbook. I save it. I can adjust some of the settings. Should we optimize it? Should we allow permissions? Should we allow certain users to look at the data set, the workbook or not? But once I've saved it, I can go in the Finder, and then I can select to run the workbook. What Datameer does now is it transforms the workbook I just defined, the process, it transforms it into a MapReduce job, and then it connects to your Hadoop cluster and tells Hadoop to crunch the numbers, and then it comes back to you and tells you, I'm finished. So usually if you have a big Hadoop cluster, you could have done gigabytes of data right now. Since this is a demo, I just have a local Hadoop installation here in my notebook, and I just work with a slightly smaller file. All right, so it's finished. That means we now have the data as split in a training and a test set, and we can now go to the second step and learn and model. And the beauty of PML here is that I can use any software, any model learning software I want to use. So, for the demo, I experimented a little bit with R, but in the end I decided to use KNIME, which is open source software. You can download it on the web, it's free. And I'm going to use the KNIME mining tool to create a decision tree. So in order to do that, I need to do two things. First of all, I need to get the data out of Datameer. So I go here and look at full data. And you can see here's a training data sheet. So that's the actual full data that was computed. And I click on download and download it. Let's save it. There it is. And then I go to KNIME and tell KNIME to configure a CSV reader. So it was saved as a CSV file. So I configure that CSV reader to go to my downloads folder and take that data I just exported. And it has column headers, but it doesn't have any row headers. So let's see whether I can execute that. And yes, I get a green light. So I've just read the data into the KNIME mining system. Now, the next step is to have a decision tree learner. So I drag that here. And I have to connect the two to tell them that the data that was read in should be passed on to the decision tree learner. And let's configure that one too. In this case, the class column is already correct. I want to predict that one. I use a different pruning method, and I just have one record per node. And let's execute that one too. And we get a green light. So KNIME has just learned a decision tree from the data I gave it. It's internally saved. It's not available as PML yet. So the next step will be to tell KNIME to export it into a PML file. Again, I need to connect the two. And again, I need to configure the writer and tell them where to save the actual file. Let's put it somewhere here, and let's call it the campaign decision tree. Do we have it? And again, execute it. And now if I look on my desktop, you can see here's the PML file. It's XML, so I can open it in a text editor, and I can look at the data. It's not a black box. I can figure out if something's going wrong. I can look at the name of the attributes they used. So that's sometimes it's definitely easier to use than just a script or some R code. All right, but we have the data now. We have the model now as a PML file. So that means we can go to the third step and go back to our test data and see how well that model actually works on the test data. So for that, I go back into Datameer. And the first thing I have to do is I have to tell Datameer that I have to upload that PML file. I have to tell Datameer that it should use that PML file. And for that, I use the Zementis Universal PML plugin. I click on Configure. Oh, I have some Alt here. Let's remove that and add the new one. That is on the desktop. And I click on Save. So now Datameer did upload the PML file. So that PML file is now at my disposal in the system. All of the users can use it now. So that means I can go back to my workbook. And here's the test data. Here's a sheet with the test data. So how can I apply that PML model now on the data I have? Quite easy. It's a spreadsheet, right? So the only the easy thing you would do is you would add a new column. There it is. And you can see that there's a new category here, PML decision tree. So that's exactly the PML model I just uploaded. So that's a bit tedious now, because I am used to a bigger screen. So I have to move the thing a little bit. So what you now got to tell the formula builder is all the columns that are used for the model. So here we have age, we have job, we have balance, we have housing, we have contact, we have month. Wait, we have day and then month. We have duration, P days, and then P outcome. And we have also some of the, one of the problems with NIMES is that the decision tree sometimes doesn't consider certain columns. So these get put in the back, so the order is not the same anymore. That's why it's not as straightforward as it should be. Here we have campaign and previous. Right, but now we have them, and I can click on OK. And as you can see, I have now this new column. Let's give it a proper name. That's the prediction. And you can see that it's not too bad most of the time. So here it makes a correct prediction. These are obviously correct predictions too. This one is not a correct prediction, so it's not a perfect model. It does make some mistakes. And the next obvious step will be to figure out how many mistakes does it make on average? How good is it? How good does it predict? So how would you do that in Datameer? Well, it's a spreadsheet, right? So it's easy. Just add a new column. And here I'm going to type the formula directly. So I just ask it to compare the Y column, which is the true label, with the prediction column. And that gives me a Boolean value. So it says it's most of the time the prediction is true. Here we have a misclassification, so it's false here. Again, let's give that a proper name. Let's say that's the column that tells me whether the prediction is correct. And the only thing that's missing now is I have to figure out how often there is a true prediction and how often there is a misclassification, how often there is a false. How would I do that? It's a spreadsheet. So just add a new sheet, and again, I'll just type the function. I just do a group by. So I ask it to compare to group, wait, one sec, to group test data correct. And not surprisingly, I get two groups, namely it's either false or it's true. But that's not what I was looking for. I was looking for how many true and how many false values do we have in here. So that's why I add a second column, and here I just do the group count. And now I can see that out of the 5,000 examples I have here, about 10%, about 500, get misclassified. So the error is about 5%, and it's an accuracy of 95%. That's not too bad. It's also not it's not the best possible classification. I've been experimenting with support vector machines too on that data set, and they tend to get better results. So I'm kind of running out of time, but I guess one of the things I could show you is how to go not to NIME but go to R and learn a support vector machine in R. Then go back into Datameer and compare the support vector machine with the decision tree. I could show you how to tune the parameters, how to change parameters so that I get a better model. And finally, and I guess that's a big advantage of Datameer too, I could show you how to visualize the data and prepare an infographic so that you can present the results to someone who doesn't know too much about support vector machines and statistics. All right, but I'll stop it here. To summarize, I guess what I've done here in a few minutes is I've taken data, potentially tons of data, if I've had to use a real Hadoop cluster. I've split it into training and test set. I've learned a model using a third-party tool. I've imported that model, and I've evaluated the model and figured out how good it is. And all of this in a few minutes, as opposed to of days, weeks, or even months it would take if you would go in a traditional way. Right, but I'll turn back to Michael for the wrap-up. Yep. Wait a second.
Perfect. Thank you. Are we still on? Okay. Thank you, Ulrich. I think the major message was clear: simplicity. So if this looks too simple to be true, it's not. It is as simple as that. When you have a common glue between different tools that you can move assets from one environment, from one vendor. Here we had 3 different vendors in the same mix in a few minutes. So I guess the message going back for you is, as maybe the owner of a Hadoop infrastructure, is you can leverage the Hadoop infrastructure today for predictive analytics scoring. You can minimize the data movement, you can execute those models massively in parallel, and you can scale that with your business demand. So if your business users come tomorrow and say, we'd like to make predictions on our campaign management, can you do this on Hadoop? You can. It's very easy to leverage it, through the Datameer user interface. Anyone can import those models. Your analytics team only has to send you that particular model as a PML file. You deploy it in less than a minute. You apply it, and there's no coding skills required. So really, taking complexity out of that whole process is what we emphasize. And last but not least is you avoid vendor lock-in. So it's an open standard. There's no proprietary code that needs to float around, needs to be documented or otherwise managed. And it allows you to have the flexibility to select the best of breed toolset. So you can select the best of breed data mining tools. If it's R, if it's KNIME, if it's SAS, SPSS, the choice is yours, and you put it on top of the Hadoop infrastructure to execute it. Needless to say, it can also go elsewhere. It could go into some of the major databases that execute PML. It could go into a separate campaign management system that in real time makes recommendations to a new customer coming to your website. The message is really that predictive asset, that predictive model can go anywhere. It needs to go after the fact that you developed it through the standard. And with that, I'd like to conclude the presentation. There are a few resources here on the slide that you can learn more about PML and the products we mentioned today. And then open it up for questions and answers. Thank you for your attention, and please use the microphones for your questions so everybody can also hear that part of the discussion. Thank you. Go ahead.
Hi, I'm Sai from Kabam. So we use Datameer. I was just wondering if you guys support the REST API to kind of have this entirely programmatic, as opposed to someone having to manually deploy the PML file and then run the model. Whether it's easier to kind of do it in a closed loop and kind of do it programmatically.
Fully integrated, basically.
Yeah.
Take that.
Yeah, the answer is not yet.
Okay.
So we for the new version of Datameer 2.0, we were preparing and getting the plugin working 2.0, and we found a couple of rough edges, and that was certainly one of them. So yeah, there's going to be happening something soon.
And then the second question is, when you guys use KNIME, I mean, I'm sure you guys use a relatively small test set, right? Because I guess the way KNIME runs, I mean, you can't kind of parallelize it or distribute it. I mean, it's probably going to be running on your analyst's workstation or something like that, right?
They do have a cluster version as well.
Okay.
So in principle, you would do that outside of Hadoop. You can have a KNIME cluster that scales up. So there's different options. Again,
okay.
You pick the tool you like. It's certainly not memory bound, so
okay.
It's pretty powerful as it is, even on a single node.
Okay. Fine, thank you.
Hi, Dave Renke from OpenBI. What do you have to deploy to the Hadoop cluster in order to process the model in the cluster? Anything? Or is it being all generated as Java, MapReduce that you're sending in?
Yes. Yeah. So basically the models transition to the cluster, and there's a core engine that basically interprets those models and basically executes them. But so each, it could be something that's integrated into a direct MapReduce job if you would want to write Java against it.
Well, I meant the example you just showed here, right? You deployed PMML to the Datameer front end, the client, and the client submitted MapReduce to the cluster to process the results, correct?
Yeah, what happens below the surface is that you install the PML plugin into Datameer.
Yep.
And then Datameer, when it deploys the job to Hadoop, it takes some part of the plugin, namely the engine that does the prediction, and transfers that to Hadoop in the job jar. And then it just transfers a description of the model, and then the model gets applied.
And so Hadoop's handling it with the distributed cache then? It's taking the jar and...
Exactly.
Okay.
It's done automatically in Datameer. You don't have to deal with that.
Hi, this is Supreet. I'm still trying to understand the portability for PML. So let's say I defined a model in R that used random forest or some other recommendation algorithm. When I extract that model in PML, what happens to the portability of that machine learning algorithm?
It's fully portable, so the representation is just an XML-based description of your model, basically. So everything that you did in your model, the algorithm, as you trained it on a particular data set, is going to be transferred, including pre-processing derived values potentially from raw data to elements that you need as part of the entry to your model itself.
Yeah, so the assumption is that, let's say, a random forest algorithm, it's available as an R package,
yes.
But in the Hadoop cluster, that algorithm is not available, or it's available in Hadoop, for example.
Yes, yes. So the plugin basically makes it available to you. So the plugin essentially is has or knows a collection of algorithms, a pretty long list of algorithms that are part of the PML standard, random forest being one of them, decision trees, neural networks, everything. So with transferring that description of your model, the execution will happen through the plugin, basically, on the Hadoop side. Any more questions? Yeah, the first question on the automation part, that's actually a very interesting concept also for rapid model building, automated deployment, and automated scoring processes. So if you have a full round trip there are ways to do that, to automate those pieces. We've done that outside of Hadoop before, but it is, I think, kind of the next step of industrializing predictive analytics. So moving away from it as an individual art form, building one particular algorithm. Once you have a set of algorithms that you know perform well, you automatically retrain those models on a regular basis, automatically deploy those to your cluster or to your web services environment, and automatically use the best model you can do every night, or however frequently you can update those models. This is kind of the next step, I think, of the evolution for predictive analytics, that you can automatically retrain, automatically deploy, and automatically use that. And the standard, of course, there helps you to move those files very, very efficiently. Okay. One more question?
Yeah, two questions. Sorry if I missed that part earlier, but does this solution provide a way to compare models?
You would basically run multiple models and then compare the outcome of it. Like what Uli did is like look at true and false. You have predicted values or expected values, and you look at the result of your model. So the same way you could have 10, 20, 50 different models, and you could say, okay, let's test those and look at the outcomes. And of course, that means you have the ground truth somewhere,
right,
so you can look at the performance.
But it's more like one-dimensional. I mean, if you're comparing models, you might have more factors than just, there's variance. There's areas where it's showing up true more often than not. So you could get into deeper analysis. I was just curious about that. Mm-hmm. The other part was after you do the test data and you think you have a decent model based on the test data and you deploy it, is there any kind of feedback loop to because now it's running on terabytes and you may be collecting feedback on certain things to say, hey, you know what, this actually turned out to be false. So can I have some data on how my model ran? And then kind of, if I have to improve it, go back and improve it or change it?
I think that's the perfect application for that is the visualization part of Datameer, where you look at, okay, this is how the model, true versus false, or certain lift performed on the test set, and then you look at the same as part of the total data set that you run or next year's data set, and you see that the population shifts. And through the visualization, it's going to be very easy for you to look at the outcomes. And
so it can handle that large data
yes,
set. Okay,
yeah.
Thank you.
That's the whole point, too, of the user interface of Datameer, that you can iterate quickly, that you can be agile about it. And if it turns out that something doesn't work, you can just go back to your workbook, change the things that don't work, or try new things, and then click on the button to test whether it makes sense on the big data.
I think it's a great environment for experimentation. So data scientists always have the issue to access big data sets, and this is, I think, a very easy way to access and rebuild models and test them, in addition to all the other benefits that we mentioned earlier. But I have one more question. We have 30 seconds.
It looked like the example that you showed used very structured data. How does it perform with kind of semi-structured data or something with not as defined a structure?
It does. I didn't show you, but we have all the functions that you would expect from Excel, but we also have functions that deal with semi-structured data, like JSONs or XML, but also stuff like text. So if you go to our booth, I have a demo where I can show you how text processing would work, how you would deal, let's say, how we do sentiment analysis with text data. That's possible too. That's the nice part of having a spreadsheet where you don't need a schema. You just build your schema whenever you need it.
Thank you.
Okay. Well, thank you very much for your attention, and hopefully we'll see you at the booth later. Thanks.